Okay, we're starting straight. Starting immediately. We all know the definition of tangent lines, so we're not going to waste time there. So we remember that a tangent line is a line that intersects a circle at exactly how many points? Savannah? Is Savannah there?
One.
I said a tangent line is a line that intersects a circle at exactly how many points?
One.
One. And what is the point of intersection called? What do we call it? The point P here. What's the
Tangency.
Okay, point of tangency. That was beautiful. So here, as you can see here, L, the line L here, or you can also call it LP, line LP. Line LP. Is tangent to, what's the name of this circle? And the circle is always named after the center. So Tyler, what's the name of this circle? Look at the center and then name it. He said, okay, circle O. So here, as you can see, LP, this line is tangent to this circle called circle O. And then what is the point of tangency here? P. So here, which means, and when you check this new drawing down here, what do you observe? The tangent line is AB, and then AP is, what does AP represent? To the circle, what does AP represent? What is the name of the distance from the center to any part of the circle? You start with R, radius. So as you can see, AP represent the radius and AB represent the tangent line. So what do you see in between them? Check here, what do you see between them? The box here, what does it represent? What does it show? When two lines meet and you have a box in between, what does that mean? That means they are perpendicular. Beautiful. So here, a line segment is tangent to a circle if and only if it is perpendicular . Oliver, sorry, did I give you this? I'm so sorry, sir. Perpendicular to a radius drawn to the point to the point of tangency, okay? So another definition here is that a line segment is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency, okay? So it means if you have a circle and then this green line is called tangent line, that means the point of tangency, if the point of tangency is R, it means the distance from R to the center is gonna be a perpendicular line to the green line. So meaning this angle will be 90 degrees. So here we're gonna say A to B, since it's a line, is tangent to Here, the circle here is P because the center is P. And then the condition is that this is biconditional if and only if the line segment AB, the line AB is definitely perpendicular. This shows perpendicularity. So AP. AB is a line. That's why we have that bar and then the two arrows. And AP is just a line segment. So meaning it has a beginning and end point. Who just joined us? Ben, welcome. Ben is here, our good friend. So here, we're gonna just solve these problems and then we're done. Avalon here, what do you, in the first problem here, what is the, can you name the tangent line? What is the tangent line here?
AB.
AB, beautiful. And then what is the radius here, Avalon?
PA.
Okay, PA, good. And then since we said the tangent line, the radius and the tangent line form a right angle, which means if we join P to B, then we're gonna have a right triangle, isn't it? Then how do we show that AB is indeed the tangent of the circle? So we're gonna make use of Pythagorean theorem, okay? So what does Pythagoras say? What is the longest distance in this triangle here? The longest distance, PB. What's the longest side in this triangle, ABP? One side is 17, one is 15, one is 8. PB, okay. So PB, we're gonna call it A, we're gonna call it C, and then the two other sides, we're gonna call them A and B. Then let's use Pythagorean theorem to see if indeed the sum of the square of the legs gonna be equal to the square of the hypotenuse, okay? Then Pythagoras says A squared plus B squared is indeed C squared. Let's see if it's right. A here is 8, you square it. B here is 15, you square it. And then C here is what? 17, and then you take the square. What is 8 squared? Aiden? Is Aiden there?
Yeah, what did you say again?
What is 8 squared?
64.
64. What is 15 squared? Aiden, 15 squared.
225.
Okay, 2 to 5. What is 17 squared, Aiden?
289.
And what is 64 plus 25?
89.
289, okay.
Wait.
So as you can see, 289 here equals to 289 here. So that means this and this have something in common. Say here, yes, AB is indeed a tangent to circle P. On the other side, Aiden, what is the tangent line here in the next problem here? Is it in there?
Yeah.
Okay, what is the tangent line here? A tangent line is a line that touches the circle, that's outside and touches the circle at exactly one point. So what's the tangent line here? It's almost the same problem, just that this time around, we only turn the circle, the triangle upward by maybe 90
So
degrees.
would it be 11 squared plus 14 squared.
Okay, being equals to 5 squared, isn't it? Okay, because here, as you can see, the tangent line here is AB, and then AP here is a radius. And since the point of contact with the tangent line and the circle is P, then by our statement here, it means they're going to be perpendicular. AB and AP will definitely be perpendicular, okay? Which means if we join the ends of this, the radius, the center of the circle to one part of the tangent, we're going to have BP. And then what does Pythagoras says? It says here with the longest, don't look at the numbers, just base your assumption on your knowledge of Pythagorean theorem, which says, assuming there were no number here, so it means this is the longest distance, as we can see. And then the other guys are just the legs. Then we're going to take the square according to Aiden. When we take A squared plus B squared, according to Aiden, is C squared. A happens to be 14, B happens to be 11, and then C happens to be what? C happens to be what? 5 squared. So as you can see here, this is not going to work. But the only thing we could have done here is, because when you take 14 squared, 14 and 11 are bigger than 5. So which means the side here, this 5 here only represents, this 5 here only represents this part, okay? 5 represents B to the circle. And then from the circle to P, what do you think the purple side going to be? What do you think the dimension of the purple side going to be? 16. Why? No, just not green plus purple, just the purple side. The purple side represents what? A radius as well. And we know that what's the value of the radius here? 11, because AP is a radius, so that means from this purple side from here to here gonna also be 11, isn't it? Then adding these two numbers will be 16, okay? Then you can then use Pythagoras again. This is C, okay? This 16 becomes C, then you take A squared plus B squared and C squared. A here is 11 squared, B is 14 squared, and then C equals to 16 squared. So what is 11 squared? Oliver, what is 11 times 11? Okay, 121. What is 14 times 14? 196. What is 16 times 16? 256. And what is 121 plus 196? 317. And the other side there, we have 256. Are these two numbers equal? Wrong. Which means no. Here, AB is not a tangent, because when we use Pythagorean theorem, the law does not apply. We don't have, equal numbers on both sides of the equality sign. Then here it's no, because 317 is never 256. On the other side, we have 289. When Aiden did this, 289 equals to 289, which is exact. Then we're gonna move to the next one. Savannah, this is your assignment. So Savannah, here, what is the tangent line here? Which side is a tangent line? Which side of this triangle represents the tangent line? Is Savannah there? Okay, JK. And then what is the radius?
L.
LJ.
LJ.
So here it means, since she was able to get the tangent line and the radius, so you're gonna definitely the definition of tangent says these two lines gonna definitely be perpendicular, which means in nature, if you join the endpoint of these two lines, we form a right triangle. And then we want to find the longest distance, which is x, which we call hypotenuse in Pythagorean theorem. So this is going to be C, this is going to be A, this is going to be B. Sometimes, our A is mostly, the shortest leg, okay? But if you interchange the position, it doesn't really matter. Then by using Pythagorean here again, A squared plus B squared equals to C squared. Our A guy here is 7, B is 19, and C is the unknown guy. Savannah, what is 7 squared? Is Savannah there?
49.
What is 19 squared? 19 times 19.
361.
Okay, and when you add them, what do you have here? Add 49 to 316. 361, I'm sorry. You said 361, okay.
410.
410. And here we're looking for, here we have x squared being equals to 410. So what do we do to get x? What do you think we can do here to get x? We're looking for x, but we have x squared. So what do we do to get rid of the square?
Find the square root.
Okay, thank you. And taking the square root, what is square root of 410? What's the square root of 410?
20.24.
Okay, 20.24. I need someone else to, is Sarah back? Sue, are you there? Is Sue there? Okay, Tyler, what's the tangent line here between JL, JK, and KL? No, the tangent line is a line that is outside that touches the circle at exact, okay, JK. And what's the radius here? JL. And the definition of tangent line says the tangent line and this the radius, are always perpendicular, which means the endpoint of the radius and the endpoint of the tangent line here will definitely form a right triangle. By Pythagorean theorem, what do we do? Here, this is another problem again. The 7 is only from here to here. And then we needed to find this distance. L to the circle, because to the circle to the end, from the circle to the end point of the tangent line is 7, and then L to the circle is also a radius, then we're gonna put 11 here, okay? Since the radius here is 11, so which means if you move from the center to any part of the circle, it's gonna always be 11, okay? Then if you add these two numbers, 11 plus 7, that's 18, that will equal to C. And then you can call this guy A and then call this guy B. Then go with Pythagorean theorem that says A squared plus B squared being equals to C squared. So Tyler, what is 11 squared? 11 times 11, 121. What is 18 squared? 3. Okay, 324. Then what do we do next? Okay, since 321 is bigger than 1 to 1, then you remove 1 to 1 from both sides. Then when you do that, what do you have? (203). And then what do we do next? Square root. Beautiful. And what is square root of 203? X equals to 14.2. So here, the problem that we fixed with Savannah, he only helped us find the hypotenuse of a right triangle. Tyler just helped us find one of the side of the right triangle, which is also the tangent line. Okay, so you can do some cases, you might even try to find the radius. It depends on, you know, the configuration of the question that you know, that you face it. Then the last one here, what is the tangent line here? The tangent line is JK, okay? And then the radius here is LJ. But what do we observe? The radius is also extended to another radius so that we have JM. And then, you know, LJ here, this is 11, which means the other ones are gonna be what? LJ is 11, ML is also 11 because both of them are radii. Okay, we have 2 radii. So which means if one is 11, the other one gonna be 11 as well. So they're gonna add up to what? Both of them gonna be what? If you add these two, you're gonna have 22. And then if you join the other side to them, here you're gonna definitely have a right triangle because this and this form a right angle. Then this becomes our C, this is our A, and this is our B. By applying Pythagorean again, A squared plus B squared being equals to C squared. Nevea, are you there? Jayla? Jovara?
Here.
Okay. What is A here? What does A represent? Just read the number beside it. The letter beside.
X.
X. What is B?
22.
22. And then what is C?
25.
25. What is 22 squared? What is 22 times 22?
484.
484. What is 25 times 25?
625.
625. Then what do we do next?
Subtract 484 from both sides.
Okay, 484. 484. By doing so, what do we have? If you do 624 minus 484, what is the outcome?
X squared equals 141.
Okay, this is 5. I'm sorry, this is 5. So if S squared is 141, what do we do?
Square root it.
Okay. So if we root it, what do you have? What does X become?
X equals 11.9.
Thank you so much. So these are the things to do today. So if you check the GeoGebra very well, you're gonna see common tangent to a circle. CE here, see the tangent lines. We have CE, which is a tangent line. And then what do you see? And here we have a radius AE. And what do you see in between them? 90 degree. So once you have a tangent line and the point of tangents, at the point of tangency, if you draw a radius that passes through the point of tangency, okay, which that means the angle that is formed in between them is definitely 90 degrees. The other side too, this is another tangent line because this line touches the circle at exactly 1 point F. And then if you trace a line, a line segment from that point of tangency to the center of the circle, which is the radius, and then the angle that is formed would definitely be 90 degrees as well. And as you can see, AE and AF are 3.2 each because they are both radii. Then if you go to the homework, we have a lot of things to do there. So let's end it today here, and then make sure you